Dear students, now let me come with the coagulation process. So first thing is, this is the reactor, and to remove all the turbids, what you add is, you add alum, right? Now, after some time, what happened is, slow mixing, rapid mixing, all this alum and these turbids, these are turbidity, colloids. These are colloids. The alum and the colloids will form a sludge. Okay? And the water is free from turbidity. Now, in environmental engineering part 1, I've explained to you already, even though there is no video, what is the mechanism of turbidity removal by the alum or the coagulant, how many types of mechanisms are there, like strip coagulation, then interparticular bridging, electrostatic attraction, adsorption, those 4 techniques. And what is the mechanism? The double layer theory, the co-ions, the counter-ions, all those mechanisms that was explained before. And what is the test we have done? The jar test, to find the optimum dose of the coagulant and the optimum pH, because pH also plays an important role in coagulation. Another one is the relation between the alkalinity and the turbidity, the different types of turbidity, then the formation of larger flocks, smaller flocks, all those things was covered in the last class. So this part for the design, all this alum mixed with the colloids with double layer theory or any of the mechanisms, and they form the sludge. And now this is free water. This is completely pure water. Okay. So the environmental engineering is not free from the problem yet. We added alum, we cleared the water, but the sludge is there. This sludge is nothing. This is specially aluminium hydroxide. Okay, so it is contaminated with alum. And another one is, let me put one point over here. This sludge. What is a sludge? Sludge means it contains a lot of small particles in the flux form, in the solid form, along with the water. And the sludge may contain solid of around 2 to 5%, and remaining is water. The best example is from the septic tank, all the digested sludge, all the human waste has been digested by the anaerobic bacteria, and then along with the liquid is a black form. It comes out of the septic tank and on the drains. So on the drain is the sludge are there, but the sludge itself, to move, it contains a lot of water. So if you collected the drain water or a sludge, if you dried it, you'll find that around 90 to 95% or even 95 to 98% are liquid, but solid is very, very less. That is around 2 to 5%. Okay, so this aluminum hydroxide, it is also not completely compacted. It will be in the form of a sludge. Now the question is, when you put the alum over here, how much sludge will be formed, and what are other effects that I'm going to teach right now? Okay, so the first question is, what happens when alum mixes with water? The formula of alum is Al2 SO4 3 18 H2O. This is alum. Now this 18 molecule of water, it is mixed with this one. Sometimes during the formation of chemical complex, they are not able to crystallize. They are not able to form the solid compounds. So sometimes they added the water molecules, we call it hydration. So it will be formed in crystal, like the ice in the fridge, ice with the ice cubes, fish with ice cubes. Okay, so this is the crystallized form. So this alum, what happens is, when you mix with the colloids, whatever, it also consumes some alkalinity. It consumes, because alkalinity is a very, very common thing in water, and it forms some product. A sludge will be there, plus some water molecule may be there, and some plus something will be there. So let me elaborate. When we say alkalinity, let me remind you there are three ions responsible for alkalinity. Remember, the first one is hydroxide, second is HCO3 minus, third is CO3 2 minus. And the unit of alkalinity is always in dash milligram per liter as calcium carbonate. But it doesn't mean that the water contains calcium carbonate. Since there are three different ions, only two may be there, only one may be there, but we don't know which one is present. So, but we estimated alkalinity by using phenolphthalein and methyl orange technique, titrations. So when we find it out completely, we rather mix it as in terms of calcium carbonate. Another example I'll give you, as I always give, this guy is from Europe, he's pound, he's a dollar, and he's a Japanese yen. The three teams, $100 plus 100 pound plus 100 yen. It cannot be 300 units, right? So everything they converted in terms of calcium carbonate. So I have three friends. When they brought it, $100 will be around, say, around 75 into 100 rupees. Similarly, 100 pounds, maybe 100 into 80. Okay, so then we convert it into everything into rupees, and we make it as common unit as rupees. But it doesn't mean that I have currency in rupees, no. So we convert just in terms of calcium carbonate, because calcium carbonate, everyone knows, the molecular weight is 100 grams per liter, right? So it is very easy to multiply 100 simple units, or its equivalent weight is 50 grams per liter. That is 100 by 2 equivalent weight. So I'm just trying to remind you the basic fundamentals. So out of these three, any alkalinity may be present. Now let's assume one of them. Okay, let's assume one of them. So let me write it again. This equation can be written as Al2SO4 3 18H2O. Let's say we have HCO3 minus. So it will be calcium HCO3, calcium is 2, so 2. Okay, they will give out. So in order to balance it, we will get first, remember, AlOH3. Aluminum is 2 molecules, so you will have 2 molecules here. Okay, and then this calcium will be mixing with sulfate, and they'll form calcium sulfate. But mind you, I don't mean to say that the water contains calcium. If it's magnesium, fine, magnesium, because valency are same. If it is some other compounds, it may be same. But assuming that it may be in terms of calcium, a divalent compound, we are generating. So since calcium sulfate will be there, sulfate is 3, calcium will be there. So calcium sulfate formula is calcium sulfate, right? So since sulfate is 3, calcium 3 will be there. So this will tricalcium silicate, not silicate, sorry, sulfate, and then aluminum hydroxide will be there. Then this water molecule will be released automatically, plus some carbon dioxide. This, how many carbon? 3 2s are 6. 6 carbon dioxide will be there automatically, and this carbon dioxide will be released. Okay, so you please see here this equation. 3 is there, 2 is there, this 3 will be here, this 18 molecule will be same, and plus we have 6 molecules of carbon dioxide. This equation is one of the best example. That means an alum consumes 3 moles of alkalinity to produce 2 moles of the sludge, and it releases 6 moles of carbon dioxide. Okay, so let me come to the question again. Another example I'll give is, if some of you, because many of the NIT students are quite very arguable, which I really appreciate, If it is not HCO3, then what will happen? SO4, 3, 18H2O plus. If I say, no, sir, उसको कैल्शियम हाइड्रोक्साइड बनाओ, ठीक है? It's calcium hydroxide, maybe magnesium hydroxide, maybe other hydroxides. Okay, so based on this, it may be again twice AlOH3. Sludge is there plus. So calcium into sulfate, right? So calcium sulfate will be there. Al2OH3. Al2OH3 will be there. OH2. So this will be 3. So this calcium sulfate will be 3. So OH2 is there. OH2 into 3, there are 6 molecules, right? Plus, how much water molecule is left? You can see over here. It's 18H2O. Okay. OH is 2 into 3, 6. 2 into 3, 6. OH is 5. Water molecule is gone. Calcium and sulfate is there. Fine. So these two equations is generally define the calculation of alum for all the evaluations. Please have a look again. So I'll say that this is sludge. Okay, fine. You should have a mugged up formula: aluminum 2, sulfate 3, 18H2O. Now we may use any one of the equation. Now the question that is going to come is, if this much of alum is put, how much carbon dioxide may release? If the question comes this way, how much carbon dioxide is released? The greenhouse. Fine. Then that means the alkalinity present will be either in the form of CO3 or CO3 2 minus, because carbon should be there. Okay, but we are not very sure it is bicarbonate or simply carbonate. So rather we can use a simple equation to balance the equation. Okay. If there is no estimation of any or evolve any carbon dioxide, we can simply use this equation also. But if this carbon dioxide is formed, that means it contains carbon molecule in the alkalinity. So hydroxide is not predominant, but rather carbonate or bicarbonate are the predominant chemicals. Okay, alkalinity. Now over here, before doing the calculations, let me come back here. See, what is the molecular weight? Molecular weight of alum. That is, aluminum is 27 into 2 plus sulfate is 32 plus oxygen is 16 into 4 into 3 plus 18 into hydrogen is 1 into 2 plus 16. Okay, I won't take it very for long. This value comes around 666.7 grams. Okay, it's not very difficult to remember. Just to make the funds, if you read the Bible, this 666 is the number of the beast. So don't forget, elements is the number of the beast. Okay, so one molecular weight is for alum, we have got it. Now, for the aluminum hydroxide, what is the molecular of aluminum hydroxide? AlOH3, twice. Because in both the cases, twice aluminum is there. So this is 2 into, right? 27 plus 16 plus 1, 17 into 3. 51, 58, 68, 78, 78 2s are 156 grams. Okay, So molecular weight of the sludge is 156 gram and that of alum is lump sum 666 grams. Now the question is, remember, therefore 666 gram alum yields 156 gram of dry sludge. Why I am saying dry? Because this is still a solid. Some part will be coming for the water molecule. Therefore, 1 gram of alum yields 156 divided by 666 gram of sludge. So these are the points you have to remember. Similarly, you can say 666 gram alum will produce how much carbon dioxide? 6 molecule of carbon dioxide. That is 12 plus 16 to the 32, 30 to 34, 44. 44 into 6. 6 4 to 24, 6 4 24, 26. 264 grams of CO2. Symbolic means it's escape out. Fine. So one is 156 divided by 666. 0.234. This is 0.234. Okay. 0.234 gram of sludge is produced by 1 gram of alum. Similarly, you can find here 264. 264 is correct. Carbon dioxide is 12 plus 16 into 2 plus 12 is equal to into 6 is equal to 264 divided by 666. 0.396 is equal to 0.396 gram of CO2 is produced by gram of alum. These points you can remember, or it's not very difficult. Even you can derive. Even you can derive at any time. I'm getting for. Okay, I think it's not very difficult. You can have a look again. Let me explain again. When you added alum in the water to remove all these turbidity colloids, if alkalinity is there, it consumes the alkalinity, it forms a sludge along with the colloids and then a water molecule. Okay. So alkalinity responsible is 3 types of ion. One is carbonates, bicarbonates, and one is hydroxide. So if you consider HCO3, alum plus equivalence thrice calcium HCO3, it forms this equation along with 6 molecules of carbon dioxide. Now, or in other case, if hydroxide is there, it produced 18 molecule of water and twice aluminum hydroxide. Okay. Now, by using this, the molecular weight of alum is 666 gram, whereas molecular weight of a sludge is 156 gram. Therefore, 666 gram of alum yields 156 gram of dry sludge, that is 0.234 ratio. And 666 of gram alum produce 264 grams of carbon dioxide released in the atmosphere. That is, every gram of alum you use will give out 0.396 gram of carbon dioxide released in the atmosphere. Okay, so these are a few questions. Can I have a look? Now we will solve the equations. So this video is only till now 19 minutes. I can still continue it. Okay. Actually, I'm taking this online class due to the COVID situation, and This is for NIT Manipur students, the third year, fifth semester students, which is only 28 students. Sometimes I'm not a YouTube blogger, but what I'm very surprised is I came around that it's around 110 or 111 subscribers. So probably I feel like some other outside students, maybe a former NIT Manipur students also, maybe. Even if it combines, it cannot be more than 60 or 70. So I hope many students benefit from this class. Okay, now let me solve you one problem. A simple question is there. Question is, an alum of 60 milligram per liter is used for coagulation. I won't write it fully, okay? And then the question is, calculate the natural alkalinity consumed in the process, okay? Number two is, how much OH2 or hydroxides or sludge are formed. Okay. So what I'll do is, as I told you before, I forgot the things. Simple, I'll do 666 gram produced. How much is that? Alkali, how much alkalinity was consumed? Just now I wrote it, I forgot it. That was 666 gram produced. How much alkalinity? 3. Okay. Now I got it. So in that equation, we use twice Al2 SO4 3 18H2O plus thrice calcium HCO3. Correct? Fine. Now from here, how much alkalinity is consumed is, you can see over here. There is 2 into 666 gram consumes 3 into, okay, this is I'll say as this is 3 moles. Don't try to calculate this part because calcium will be present or not. Rather, this is 1 mole of alkalinity. So I'll say this is 3 mole of alkalinity as calcium carbonate. Okay, so 3 into 1 mole of calcium carbonate is 100. So I'll say 100 grams of alkalinity as calcium carbonate. Therefore 1 gram produced. My previous question may be then probably wrong. It is not 666 gram. Oh, Al2. Oh, it's 2 is not there. 2 is not there. Correct. So 666 1 gram produced. 1 gram produced. 300 divided by 666 gram of alkalinity as calcium carbonate. Fine. Now, alum uses 60 milligram per liter. Therefore, 60 milligram per liter alum consumes 60 into 300 divided by 666. Since it is gram, it is gram. Since this is milligram per liter, you can put it as milligram per liter. Okay. of alkalinity as calcium carbonate. So 16 to 300 divided by 666. 16 to 300 divided by 666, right? 60 into 300 divided by. So this is 27.02 milligram per liter of alkalinity as calcium carbonate. One part finished, right? Huh. So the next part is how much hydroxide is formed. Please copy it down. 666 gram of alum consumes 3 moles of alkalinity. This you don't have to find as molecular weight of calcium into whatever. This is one alkalinity equivalent to 1 mole is equivalent to 1 mole of alkalinity as calcium carbonate. Okay. So finally, if you use 60 milligram of alum, it will produce 27 milligram per liter of alkalinity. Sorry, it will consume. So my next part is how much sludge will be produced. Okay, for the sludge, again 666 gram of alum produce how much hydroxide? I said it is AlOH3 2, right? So this is around 16, 17, 51, 56, 78, 156 gram sludge. Therefore, 60, let me shortcut, per liter of alum yields 156 divided by 666 into 60 is equal to 156 divided by 666, 14.05 milligram per liter of sludge. I'll say it's a dry sludge or hydroxide. That's all. Okay? Please check it out. It's a very simple thing. Let me come to the next a little bit of complex question. Okay. Now let me do a very complex question. This type of questions, many similar questions are there. You please try to find out and check it yourself. Let me give, because every problem, different types of problem in the same topic, if I keep on doing it, it'll consume a lot of time for me. Okay. So now let me continue with one question. Uh, coagulation, a coagulation treatment plant, which has discharge is equal to, let me shortcut, 0.5 meter cube per second is dosing. Dosing means the dose, and alum at 23 milligram per liter. The raw water suspended solids. The raw water has suspended solids 37 milligram per liter. The effluent is 12 milligram per liter suspended solids. Sludge is sludge is 1% and specific gravity is called 3.01. Estimate volume of its day. Okay, this is one of the very combined questions. Fine. Now, let me explain the questions. See, this is very important. Say, for example, this is a water treatment plant. What I mean to say is, this discharge is coming with Q is equal to 0.5 meter cube per second. My dear students, one picture speaks 1,000 words. So if you interpret the question this way, it will also add some few extra marks. I mean to say, it please examiners, create a good mood. I always make a very ugly drawing. Okay. Now, when the water is coming with the 0.5 meter cube per second, it also brings some suspended solids of 37 milligram per liter. This one. Okay. So, this coagulation tank will be having two different types of sludge. Number one is the sludge of alum. The number two is already suspended solid is there. So this also will settle down over here. So when it goes out, it goes with TSS solids effluent is equal to 12 milligram per liter. So this 12 milligram per liter of suspended solids, because 37 milligram per liter, due to a particular hydraulic rotation time, it will settle down some part. So 37 is gone, 12 is coming out. That means 25 milligram per liter has been settled over here. Okay, so this is TSS part. Now our concern is this part is sludge. It is a heap. Okay, and this is number one is Al2OH3, number one. Number two, maybe some inorganic part, this suspended solids. Is it clear? Now, this sludge itself is not completely dry. What it means to say by 1%, listen here, 1% means this sludge is a whole volume. It contains only solid is, this is 1%, and this part is 99% water molecule, and this 1% is what? This part. Is it okay? Whatever aluminum hydroxide you will get in milligrams, whatever suspended solid you will get in 37 minus 12 milligram, this solid itself contains only 1%, remaining is 99%. Clear? And the last part is, this solid has a specific gravity different, and water has specific gravity. The specific gravity of water itself is 1, right? But the specific gravity of the solid, since it's heavy, it is around 3.01. So, if this 3.01 solid specific gravity is 3.01, the remaining 99% water is specific gravity is 1, then what will be this volume? What will be this volume? We have to estimate this. Is it clear? So, say for example, if you get some values, milligram per liter, then the volume will be specific gravity. Specific gravity means density of the particle divided by density of the water. So density of the particle is 3.01 times than that of the water. So you have to multiply by this one. Okay, I'll do it. Now let me explain the graph again, the pictures. There is a coagulation tank Here, the water is coming with a flow of 0.5 meter cube per second, having some suspended solids of 37 milligram per liter. It also contains some turbidity. We don't know what is the turbidity, and we don't want to know. To remove this turbidity, we add some alum. How much turbidity? We don't need to know. How much alum is required? They have done the jar test apparatus. Jar test, they have estimated that the alum required is 23 milligram per liter. Okay, so 23 for every liter, 23 milligram of alum is required. So, and suspended solids, 37 is coming every liter and 12 is gone out. That means 25 is settled down. So this combined sludge is going to form a big heap of amount. And a solid part, this sludge, it is only 1%, remaining are 99% water. Okay. And the 1% specific gravity is 3.01, the remaining 99 specific gravity is 1. So what will the total volume? That is the question. So let's solve one by one. Let me give the picture. Firstly, we have to find how much sludge is there and how much sludge is there. Okay. See here. First one is sludge by alum. If the question is 20 marks, 30 marks, you elaborate the equation like Al2 SO4 3 18H2O plus whatever 3, it gives out 6 CO2 plus AlOH3 twice plus 18H2O. Okay. So, and this one is settling down, sludge, carbon dioxide is going up. Therefore, 666 grams alum produce 156, right? Uh, 156 gram of sludge. Here we are using 23 milligram. Now, alum dose is equal to 23 milligram per liter. Okay, 23 milligram per liter. Okay, so this 23 milligram per liter is used. And what is the discharge? In 0.5 meter cube per second. This volume will be cut off, this milligram in second. That means per unit time, this much of dose is used. So this is 23 milligram divided by liter into 0.5 into 1000 liter. Let me convert meter cube so that this can be cancelled. And then second, since we are going to add the alum not in terms of every second, we are going to add only in a particular day. Let's convert a second into a day. To convert into day, it will go up as 60 seconds is equal to 1 minute, 60 minutes is equal to 1 hour, and 24 hours is equal to 1 day. Fine. I'm putting it here. Second, it should be divided by, so I'm putting it up here. Okay. So to make the things easy, we are going to convert in terms of kg. So 1000, this liter will be cancelled. Milligram we can convert into kg. So anyway, it's a lengthy calculations. Let me check it out. 23 into 0.5 into 1000 into 60 into 60 into 24 divided by 1,000,000,000. So I got as 993.6 kg of sludge. Oh, I'm sorry. That means every day this much alum is used. 993.6 of alum is used every day. Fine. Now, this produced this was sludge. Okay. Therefore, 666 gram produce 156 sludge. Therefore, 993.6 kg of alum will yield, what is that? 156 divided by 666 into 993.6 kg. Correct? Huh. Into 156 divided by 666. 993.6 into 156 divided by 666. 233 lump sum. That is 233 kg of sludge. Which sludge? Alum sludge per day. Okay? So this is going to be equation number 1. This is number 1. So this sludge is 233 kg per day. Okay? 233 kg per day. Is that okay, clear? Now we have to find the sludge. We have to find the sludge for now. Second part is sludge that is produced by TSS is equal to TSS in minus TSS out. Correct? This is equal to 37 minus 12 is equal to 25 milligram per liter is there. Okay? Into. Therefore, total suspended solids sludge is equal to 25 milligram per liter into same discharge, that is 0.5 into 1000 into 60 into 24 divided by day. This will be in terms of liters, correct? So this is, let me calculate. This is 25 into 37 minus 2 is 25. 25 into 0.5 into 1000 into 60 into 24 divided by 1,000,000. So this is coming as 1080 kg per day. This is number 2. Okay. Therefore, total dry sludge is equal to 1 plus 2. This is 1. Fine. I think it's clear. So that is 1080 plus 233 is equal to 3131 kg per day, or I can say 1.313 tons of sludge that is dry per day. Okay, so this is a total sludge that is produced. What is 1.313? This 1080 is This is 1080. Okay, so this total sludge is coming as 1.313 tons per day. Is that okay? Is the points clear? Copy it down. I'm giving you a few minutes more. Check it down up to here. Okay, let me calculate the remaining part. Fine. Now we have finished up to here. Now we know that this total sludge coming, that is 1%, is 1.31 tons. Now let's find the volume of this. Okay, volume of, therefore, dry sludge is equal to 1.3, oh my goodness, oh, 1.313 tons per day, divided by unit weight of sludge, that is 1.313 divided unit weight is specific gravity is, what is a specific gravity I've written over here? I have to see the question again. Oh, I don't have the specific gravity. That is 3.01 is equal to 1.313 divided by 3.01. So this is coming 0.436. It's roughly equal to 0.44 meter cube of dry sludge. Okay, so this part, of the 1% will occupy around 0.44 meter cube of sludge. Okay, now we say it is 1%. It is 1%, right? Since it is 1%, can I say like this? 1% is dry solids. Therefore, 99% is water. Correct? Or this combined is going to give a wet sludge. Let me remind you again, same thing over here. This part, this is the dry part, and this is the water molecule, and the whole is called wet sludge. Check it again, read it again. So if 1% is this much volume, 99% will be how much volume? We are going to estimate that. Check it please. So in the calculator, what we are seeing is, is that okay? Now I think I can rub this one off. Now, 1% is equal to 1.313 tons per day, right? Therefore, 99% water is equal to 99 into 1.313. This is 1%, remaining is 99%. Okay, so this is equal to 99 into 1.313. 30.987 meter cube. Okay, no, 9 tons per day. So 1% is this much, so 99% will be this much. And we know that this volume is 0.44 meter cube. Now, for a water molecule, volume of water is equal to 30.987 divided by its unit weight. Okay, so unit weight is nothing, it is 1000 kg per meter cube or 1 tons per meter cube. So 30 divided by 1, this itself will be 30.987 meter cube per day. Means every day this much of the volume of sludge will be produced. Therefore, total volume is equal to 1 plus 2. This is the volume created by the dry solids. This is the volume created by the water molecule. So it is 30.987 plus 0.44 is equal to 721 kV, 8 and 4 to 1 kV, 10, 4, 1 kV. So it is 31.4. So total sludge volume that is going to be produced is equal to volume of the water is correct. Oh, 99 into 1.313 into 99. 120. This is 130. 130. Sorry. So 130. 130. So this is 130. So 130. So total volume that is produced by the alum and the suspended solids is equal to 131.427 meter cube of the volume. Fine. Is it clear? But in some part of the books, what you'll find is the volume of the sludge, dry sludge, may not be again combined. So sometimes the question comes in such a way that find the volume of the wet part. Wet part is the liquid part. So liquid part is only 130. However, when combined, it will be 131.427. In many textbooks, you will find only this part. Okay. So I think the concept is quite clear. This part, or should I repeat it again? The sludge contains 1% solid. So 1% solid means already we have estimated 1.313 tons per day. Every day 1.313 tons is produced. Therefore, the 99% that is a water molecule side will be 1.313 into 99, that is 130.987 tons per day. But this volume will be different because the specific gravity of this is different and the specific gravity of the dry sludge is different. The specific gravity is 1 ton per meter cube itself, so the volume is 130.987 meter cube per day. So this is for the wet sludge. The dry sludge is 0.44, therefore the combined sludge will give 131.427 meter cube every day, per day. So this is the issue about the sludge. Okay, so with this, I have completed type 2 sedimentation, design of the circular tank, as well as when you add coagulation in the type 2, how much alum is required, how much alkalinity is consumed, how much carbon dioxide gas is evolved, as well as how much sludge is produced. In a sludge, for a particular specific gravity, particular percentage of the solids, how much volume is produced. With this, I end the celebration type 2 and its design. Okay, so today I'm completed 2 hours of classes. Fine. Thank you.